In the pre-dawn hours of December 26th, while most of the world slept under quiet skies, something inside 3i Atlas moved, not visibly, not explosively, but internally, at a level only instruments tuned to the subtlest changes could detect. It began with a series of anomalies captured by long-range gravitational modelling systems and high-fidelity spectroscopic arrays. What was first seen as a data irregularity soon revealed itself to be the signature of something deeper, a change in the internal mass distribution of the object's core, a shift in density. To the untrained eye, it was nothing, just a variation in albedo, a momentary flicker in reflected light. But for the teams tracking 3i Atlas from Chile, Hawaii, and orbital observatories, the numbers told a very different story. Across several observation nodes, the gravitational interaction between the object and surrounding particles, solar wind ions, charged dust, ambient plasma, began to change. The object's gravitational fingerprint, subtle but measurable, no longer aligned with the structure previously mapped over the past several weeks. For context, most natural comets maintain a relatively stable density profile unless they're in the process of disintegration. Fragmentation, especially after solar exposure, tends to cause erratic jets, unpredictable spin, debris clouds, and sometimes cascading breakups. But that wasn't what happened here. 3i Atlas didn't lose mass to the outside. It shifted something internally, and it did so with restraint. This shift was not chaotic. It wasn't accompanied by dust plumes or irregular tumbling. In fact, the object's rotation remained eerily stable. With no observable torque, no change in moment of inertia, and no visible deformation in the surrounding coma. The change wasn't outward, it was inward, as if something inside had moved, settled, or perhaps repositioned itself. Spectrographic data captured from the dart array in the Atacama Desert confirmed that the object's reflective index had subtly altered over a 2-hour window, suggesting that part of its internal structure was no longer behaving like compact rock or volatile ice. Instead, it began to resemble something semi-hollow, or at least less dense than previously calculated. It was as if a mass-bearing component had detached from the core, without exploding, without scattering, without even cracking the outer surface. Then came the particle data. The James Webb Space Telescope, passively monitoring infrared absorption from a distance of nearly 2 astronomical units, detected a strange pattern in the thermal curve. Where one would expect a gradual increase in surface temperature as solar radiation continued to bathe the object, the heating curve flatlined. Not only did it stop increasing, in some segments, it began to fall. This doesn't happen with comets. It doesn't happen with carbon-rich asteroids or metallic fragments either. An object exposed to solar energy in deep space absorbs, stores, and re-emits heat in predictable patterns. Unless something inside that object begins to actively redistribute its mass, or releases stored energy in a non-thermal way. By 0517 UTC, every data feed following 3i Atlas confirmed the same thing. A reconfiguration had occurred, internally. The mass profile was no longer centralized. Instruments began to log the object as possessing 2 centers of reflectivity, one large and dim, and one compact, isolated, and growing brighter. This wasn't fragmentation, it was emergence. And from that moment on, 3i Atlas would no longer be observed as a single body. It had just changed state, and something was now separating from its core. What emerged from the core of 3i Atlas in the minutes following the internal shift was not what anyone expected. This wasn't a loose rock torn away by tidal forces. It wasn't a cloud of disintegrated ice. It wasn't a spray of dust venting outward in every direction. What we witnessed, quietly, cleanly, and without any visible violence, was the birth of a separate object, and the more we watched it, the more it looked like this wasn't an accident. It was part of a process. At exactly 0522 UTC, several telescopes registered the arrival of a discrete point of light just beyond the edge of the object's main body. At first, analysts assumed it was a fluke, a lens flare perhaps, or a scattering artifact from the brightened coma. But it didn't behave like one. This point of light held steady even as the core behind it began dimming. It didn't flicker, it didn't spin erratically, and perhaps most telling, it didn't drift away uncontrolled. It moved, on its own. Over the next 12 minutes, this secondary object, what observers now call the anomaly body, began to create its own trajectory. It didn't explode outward like a chunk of ice might after sudden heating. It didn't scatter in a fan of fragments. It separated slowly, gracefully. Like something carefully released rather than violently expelled. In data overlays, the shape held its form, maintaining a tight reflectivity pattern. It was as if the core had opened, allowed something out, and then began sealing itself again. Radar reflectometry returned the most intriguing signature. Unlike traditional comet fragments, which return chaotic signals due to irregular spin and uneven geometry, the anomaly object reflected clean pulses, tight, consistent and suggestive of symmetry. Not perfect, but close enough to draw attention. It looked less like a broken chunk of a rock, and more like something structured. Meanwhile, thermal readings from the core began dropping, not gradually, rapidly. This wasn't a sign of cooling due to shadowing or dust dispersal. It looked like energy was being rerouted. The body that had just emerged was now the warmer of the two, despite having no visible heat source of its own, as if it had absorbed something from inside the core. Stored energy, perhaps, or maybe something more deliberate. Astronomers tried to simulate what they were seeing using existing models. Volatile-rich comets, layered crusts, nuclear core fractures. None of it matched. The emergence didn't cause any expected secondary effects. No spin-up, no eruption, no instability. In fact, the opposite occurred. After the separation, the remaining core of 3I Atlas grew calmer, dimmer, more inert, as if its role had been fulfilled. The anomaly body, however, began to shine. Its reflectivity increased sharply over the next hour, not enough to blind instruments, but enough to suggest that what we were now looking at wasn't passive debris. It was by all accounts operational, and this raised the uncomfortable question. Was this object always inside the core? Was 3I Atlas not just an interstellar comet, but a delivery system, a capsule, a shell? Was everything we had witnessed, the journey, the solar encounter, the tail reversals, leading to this single moment? Because now something had emerged, not in chaos, not in destruction, but like a planned release. And whatever it was, it didn't drift, it didn't fall, it moved. Within the first hour of its emergence, the anomaly body did something no cometary fragment ever has. It deviated from the motion of its parent. Not subtly, not from tumbling or jetting. It altered its path, intentionally, or so it seemed. Ground-based observation teams, initially focused on the cooling core, quickly turned their attention to the object that had now gained measurable separation. By 0611 UTC, its trajectory was no longer overlapping with the motion of 3I Atlas. It had begun curving, but not randomly, not under the influence of gas jets. The curve followed a clean radial vector that pointed away from the core and toward the solar plane. Now, natural comet fragments can be pushed by residual gases or sublimation jets, but they always show signs, spin wobble, fragmentation trails, uneven brightness. This object exhibited none of those. Instead, it held a stable heading, no rotation, no jitter. Even high-resolution telescopes, which often detect chaotic light curves from irregular objects, saw only smooth consistency. The anomaly body was not tumbling, it was navigating. Spectroscopic analysis showed no signs of carbon dioxide, water vapor or dust plumes surrounding the object. This was puzzling. If it wasn't using volatile outgassing for propulsion, how was it moving? The velocity increase, though small, was steady. Calculations showed an acceleration profile that resembled a sail, responding to solar radiation, or a precision impulse mechanism we can't yet explain. More intriguing was the directional logic. Instead of escaping along a path dictated by the momentum of its ejection, the anomaly body curved gently toward the Earth-Sun orbital plane. It wasn't on a collision course. In fact, its motion was tangential, almost cautious. But the curve had purpose. Multiple orbital analysts across 3 institutions independently concluded that its motion wasn't governed by chance. One researcher at the European Southern Observatory described it as a vector with agency. Even more confusing was the absence of spin. All known ejected bodies from comets, from the smallest grain of dust to kilometre-wide fragments, show some degree of rotational energy. This object had none. Or more precisely, it exhibited rotational dampening, like something designed to stay aligned, stabilized. Some theorized that perhaps magnetic interaction with solar plasma was influencing the object, creating a type of electromagnetic steering. But the calculations required for such a phenomenon to produce a smooth arc at that speed were enormous, and the body didn't appear to interact with the surrounding solar wind at all. It cut through it. At 6:37 UTC, its motion settled into a predictable curve, hugging the heliocentric plane. No thrust, no tail, no reaction jets, just movement, calm, measured, and aligned. The term propulsion is still avoided in official documents, but among independent analysts the word has entered circulation, because everything about the object's trajectory suggests decision, not drift, and perhaps most startling of all, its reflectivity was increasing as it moved, not erratically, not from rotation, but smoothly, almost like an energy uptake cycle, as though it had turned toward the sun on purpose, to charge or to power up. Whatever it is, it's not following a natural fall path, it's steering itself in silence. As the anomaly body began curving away from 3I Atlas, instruments refocused on the object it had just left behind, the original core. What observers expected to find was a dimming husk, a fading cometary shell losing structural integrity as its energy source detached. But what they saw next shook even the most skeptical of analysts. It began subtly, a slight fluctuation in thermal output. But within 40 minutes of the anomaly object's emergence, the core of 3I Atlas started to glow. Not in a random or diffused manner like lingering heat or reflected solar radiation. It pulsed, slowly, deliberately, and in a pattern. The first cycle was registered by the Webb Infrared Observatory just after 06:59 UTC. The surface brightness increased by nearly 11% over a period of 2 minutes, then fell again, stabilizing for another 4. The second pulse followed precisely 6 minutes later, then a third and a fourth. It was not chaotic, it was not residual heat, it was rhythm. Spectrographic readings from ground-based telescopes revealed the pulses were most intense in the mid-infrared range, between 8 and 14 microns, typically associated with surface materials undergoing molecular excitation. In simple terms, something on or beneath the surface of the core was being activated and then paused. Activated. Then paused again. Not randomly, but in a loop. Scientists attempted to fit this signal into familiar models. Could it be residual thermal lag from the sun's earlier radiation? Could internal gas pockets be igniting and cooling in succession? But those mechanisms don't repeat. They decay. They don't structure themselves into regular 6-minute cycles. One researcher compared the pattern to a mechanical signal, not natural decay, but something more akin to a calibration or system check. Almost like an idle engine turning itself over. Simultaneously, polarimetric readings recorded subtle shifts in the direction of reflected light. Each time the core pulsed, the polarization angle shifted by a few degrees, and then returned. That meant the light coming off the object wasn't just changing in brightness, it was changing in orientation, like the shape of the object itself was responding, expanding and contracting microscopically, breathing, and it wasn't emitting in all directions, it was directional. The highest concentration of infrared flux consistently radiated along the same vector, the path left behind by the anomaly object. It was as though the core wasn't simply pulsing outward, it was aiming. This became even more evident when the Soho Solar Observatory caught a faint lensing pattern in the light scattering near the object. Normally associated with gravitational bending or plasma interference, this flicker appeared exactly at the moment of the 6th pulse. Analysts began to suspect the pulses weren't just energy emissions, they were potentially field discharges. If that's true, then what was left behind is not a dormant shell, it is active, it is cycling, and it may be communicating or charging or even scanning. Because what pulses in rhythm, orients itself to one vector and emits directionally, is no longer behaving like a comet, it's behaving like a system. Roughly 90 minutes after the anomaly object began its separation, a new structure formed around what remained of the 3I Atlas core, something no one predicted and no model accounted for. It wasn't a dust shell. It wasn't the spreading debris cloud of a disintegrating comet. It was far more precise. Observers described it as a ring, though that word doesn't capture its complexity. It was circular, yes, but not thin, not fading, and certainly not unstable. The ring appeared slowly at first, like a whisper in the solar light. But as telescopes adjusted filters and calibration, the structure solidified. It wasn't an optical illusion. This was a containment boundary, a geometric perimeter. The first telescope to confirm its existence was the Gran Telescopio Canarias, followed minutes later by the LCO Global Network and the Subaru Telescope in Hawaii. The ring stretched several hundred kilometers in diameter, perfectly centered around the dimming core. It held symmetry that's virtually impossible for any natural phenomenon of that scale. More tellingly, it did not rotate with the core. It hovered in place, motionless in orientation, even as the core itself exhibited a slight axial spin. That ruled out outgassing, gravitational escape, or centrifugal plume dispersion. This was not a byproduct of movement. It was a structure formed by, or perhaps deployed from, the object. Infrared mapping revealed that the ring had its own heat signature, faint but persistent, and it did not pulse with the core. Instead, it maintained a steady emission, peaking in narrow bands associated with ionized particles, particularly oxygen and carbon-based compounds. This suggested not dust, but charged particles held in place. Immediately, scientists began to hypothesize. Could this be a magnetic phenomenon? Could the object have created a trapped field of plasma or frozen gas? That alone would be shocking, but not entirely impossible. What challenged that theory, however, was the optical reflectivity. As the sun hit the ring at a shallow angle during orbital rotation, multiple observatories reported specular reflection, the kind of light you get from metal or crystalline structures, not gases. Portions of the ring even returned a polarization profile consistent with a smooth surface. Not a random one, not fractured, not diffused, smooth. At the same time, the ring behaved oddly under solar wind pressure. Normally, structures like gas clouds would deform, twist, or trail. This ring held position. Perfectly. When the Parker Solar Probe passed behind the 3I Atlas vector 2 hours later, onboard magnetometers detected a faint distortion, a field curvature, that didn't align with the solar field map. The conclusion was cautious, but consistent. A localized anomaly was present, and it matched the shape and coordinates of the ring. This was no dust halo. No comet has ever left one behind. No natural body in our solar system has ever produced such a boundary. Symmetrical, reflective, and coherent. Some began calling it a cocoon. Others, more hesitantly, referred to it as a docking structure, or even a launch scaffold. Because this was no longer the afterglow of a dying comet. This was the architecture of an object that had released something, then shielded itself, as if it were done, and the ring was still holding. By mid-morning on December 26th, the anomaly body, the object that had emerged from within 3I Atlas, had travelled far enough from the core to become optically and spectrally distinct, and that's when the next anomaly began to surface, quite literally. Its surface began reflecting light in a way that didn't match anything natural. At first, observatories reported a modest increase in brightness. That alone wasn't unusual. Separation from the dusty coma could allow sunlight to hit the object directly. But what followed over the next 45 minutes was nothing short of perplexing. The brightness didn't level off. It began to oscillate, not like a rotating rock tumbling end over end as most comet fragments do, but in steady, predictable shifts, like panels rotating. The European Southern Observatory's polarimetry team picked up something even more revealing. Specular polarization, a hallmark of smooth, flat surfaces, not matte, not chaotic, but organized reflectivity. This is the same optical behavior you see from spacecraft solar panels, metal sheets, or crystalline materials, not from ice or rock. Then came the surface modeling. Observers used phase angle mapping, measuring the way light reflects as the angle between the Sun, the object, and Earth changes. And something odd emerged. The object was angular, not spherical or potato-shaped like most small bodies. There was a consistent edge signature that repeated every few degrees of motion. One astronomer described it as boxy, another more cautiously called it geometrically inclined. Regardless of the term, the consensus was clear. This wasn't shaped like a fragment of a comet. It wasn't irregular. It wasn't breaking down. It was holding shape, and that shape was optical, directional, and possibly engineered. As the sun's angle increased and more surface area became visible, the reflectivity index rose dramatically, far higher than what is expected from even high albedo ice. The leading hypothesis? A highly reflective surface, possibly layered or compartmentalized. The albedo was comparable to materials like polished nickel or synthetic carbon films, neither of which occur naturally in space in that form or finish, and yet there was no associated heat bloom. Despite reflecting sunlight with greater efficiency, the object's thermal signature remained cool, further suggesting that it was not absorbing energy like a natural body would. Instead, it appeared to be deflecting or managing that energy, a kind of thermal regulation unseen in any natural interstellar object. Further support came from spectrographs out of the Subaru telescope in Hawaii. As the object entered peak reflectivity, it briefly emitted a narrowband flash in the near UV range, not from ionization or gas venting, but from a surface-level interaction with light, like a lens flare from a rotating panel. That moment, caught across 3 different observatories, all but confirmed the impossible. The surface wasn't just reflecting light, it was responding to it, and still, it made no sound. No visible outgassing, no tumbling, no tail, only motion. Quiet, calculated motion. And now, directional reflection. Whatever this object is, it doesn't look like it's decaying. It looks like it's waking up. In every documented case of a comet fragment separating from its core, one expectation has always held true. Motion requires exhaust, either through sublimation, where solar heat causes volatile materials like ice to become gas and push away from the surface, or through gravitational ejection. But this new body, this smooth, reflective anomaly, had neither. It showed no coma, no halo of gas, no wisps of dust, no trace elements trailing in its wake, and more importantly, no jets, yet it moved. By 11 UTC, the object had already deviated from the expected inertial path by nearly half a degree. That may not sound like much, but in celestial mechanics, that's a significant shift, especially without visible force. It wasn't coasting on momentum, it was altering its path. When teams at NASA's Deep Space Network recalculated its velocity vector using laser ranging and Doppler echo, they confirmed what other global stations were beginning to see. This object was accelerating. The increase in velocity was small, only a few meters per second, but it was continuous, not abrupt like an impact would cause. It was controlled, and it showed none of the drag one would expect if it were pushing through a dense dust field. Its profile cut through space with no frictional signature. The absence of traditional propulsion mechanisms led analysts to propose the only plausible solution that physics still allows: solar radiation pressure. A sailing mechanism, not unlike the theoretical concepts Earth-based scientists have toyed with for decades. Thin, ultra-reflective surfaces capable of capturing momentum from sunlight itself. But for solar sailing to work at this scale, you need structure, flat panels, high reflectivity, precise angling, and most importantly, mass efficiency. The lower the mass and the higher the reflectivity, the more responsive an object is to light. This object seemed to match all of those criteria, except there was one problem. No known comet fragment could naturally meet those criteria. Its density appeared too low, its surface too smooth, its response to sunlight too exact. The math aligned better with materials used in Earth-based experimental spacecraft. Ultra-thin carbon sheets, reflective films, graphene composites. But those materials don't grow inside comets. They're built, manufactured. So how do you explain something that behaves like a sail, but comes from inside a supposedly natural object? Some theorized it was an ancient probe, perhaps dormant until now, using stored energy to maintain orientation. Others speculated that the object wasn't accelerating at all, but that space itself was reacting to its presence, like a localized manipulation of the solar field. A far more radical idea, but one being quietly modelled by field theorists. One thing remained undisputed. It was no longer bound to the same path as 3I Atlas, and it was not being dragged. It was going, somewhere. No gas, no engines, no noise, just motion, deliberate, silent, and in complete defiance of everything we expect from nature. By late morning on December 26th, every high-gain antenna and deep space radio array across both hemispheres had quietly shifted part of their focus. The visual data alone was no longer enough. Something had broken off from the core of 3I Atlas. It was accelerating. It was reflecting. But was it transmitting? For nearly 4 hours, the answer appeared to be no. Every standard frequency band, from deep ELF and VLF used to measure planetary resonance, all the way up to the GES range reserved for high-speed telemetry, returned silence. The object wasn't emitting, at least not in any spectrum we could easily detect. For many, this was confirmation that it was still a natural body, perhaps a strange one, perhaps shaped by forces we didn't understand, but natural. And then, just as the global teams began to stand down their active monitoring sweeps, it happened. At 11:46 UTC, multiple independent observatories detected a single, sharp radio pulse. It wasn't long, just under 0.8 seconds. And it didn't repeat, but it was there. The first to catch it was the South African Meerkat Array, which had been performing passive monitoring of the object's trajectory for signal drift analysis. Then came confirmation from LOFAR in the Netherlands. Minutes later, the Greenbank Telescope in West Virginia picked it up as well, though only in historical data, having buffered the relevant band as part of a background sweep. The pulse was not strong, weaker than the cosmic microwave background at its peak, but it was clean, narrowband, centered around 1420 MHz near the hydrogen line, a frequency long considered the quiet zone for interstellar listening. The profile didn't resemble a natural burst from a pulsar, nor did it carry the broad-spectrum noise of a solar flare. There was structure to it, one harmonic spike, then a flattening, and then nothing. No follow-up signal, no Doppler shift, no lingering echo, just one clean pulse, emitted from the exact region between the main core of 3I Atlas and the now independent anomaly object. What was more intriguing than the pulse itself was the timing. Just minutes before, the core of 3I Atlas had issued its 10th visible infrared pulse, part of the slow rhythmic pattern that had been playing out all morning. Analysts mapped both timelines side by side and found something startling. The radio pulse corresponded to a precise midpoint between two infrared emissions from the core, as if it had responded, not in visible light, not in heat, but through a completely different medium. Some tried to frame it as coincidence. Others proposed reflection, perhaps a terrestrial signal bouncing off a dense surface. But that didn't explain why 3 globally separated observatories caught the same signature at the same moment, with slightly different angles of incidence. And more strangely, there was no backscatter. The signal didn't bounce. It terminated cleanly, absorbed or silenced at its destination. Several theorists immediately suggested electromagnetic discharge, a spike from an interaction with the solar wind or ambient plasma, but the frequency profile didn't support it. It was too narrow, too focused, too intentional, and the source vector, between the core and the anomaly, suggested not a flare, but a handshake, a single, directional burst, from one to the other, like a final command, or a release. From the earliest observations of 3I Atlas, there was always one feature that refused to behave like it was supposed to. It was the so-called anti-tail, a narrow structure that pointed not away from the sun, as all cometary tails do, but directly toward it. At first, it was dismissed as a projection artifact, a trick of orbital geometry, caused by Earth's viewing angle intersecting with dust particles lying in the comet's orbital plane. But as more observatories began tracking the object across November and into December, a pattern emerged that couldn't be explained away so easily. The anti-tail didn't fade with changing angles. It didn't diffuse like scattered dust. It remained coherent, narrow, and persistent, always pointing back along a specific vector, as though it was tethered to something far more stable than vaporized debris. It became a point of fascination among astronomers and a growing anomaly among physicists. No known comet had ever exhibited an anti-tail that remained so geometrically rigid for so long, and so clearly aligned against the standard laws of solar radiation pressure. And then, on the morning of December 26th, it vanished. Not gradually, not with a flicker. It disappeared. Just past 12:03 UTC, Live optical feeds from 6 different observatories showed the anti-tail still present. Faint, but intact. Then, within a window of just under 90 seconds, the structure collapsed completely. No spreading, no fading, just gone. This wasn't a dissipation event. There were no particles left behind, no light scattering along its length, no dispersion pattern across the orbital plane. Instruments that had been measuring the density of the feature, using occultation and shadow mapping, returned nothing, a hard drop to 0. It was as though the feature had never existed. And that's where things get strange. Normally cometary tails are products of outgassing, visible trails of gas and dust shaped by solar wind. The ion tail, composed of charged particles, is always pushed directly away from the sun. Dust tails curve gently, but anti-tails, they're rare, and when they appear, they usually persist only when viewing angles are ideal. But the 3i Atlas anti-tail had defied that logic for weeks. It stayed visible through angle shifts, through vector changes. Even as the anomaly object emerged, the anti-tail held strong. So why would it vanish the moment that object began to move independently? That question became even more pressing when high-speed imaging revealed the precise moment the feature disappeared, exactly 34 seconds after the radio pulse detected between the two bodies. The correlation raised a terrifyingly elegant possibility. What if the anti-tail wasn't made of dust at all? What if it was a tether? Not physical, not cable or structure, but field-based. A magnetic corridor, a plasma bridge, a tether used for containment, or communication, or transfer. If that were true, then its disappearance wouldn't be the tail vanishing. It would be the connection severing. One object moved out, the other pulsed, and the anti-tail was cut. That would explain the sudden collapse, the absence of lingering particles and the hard data drop in every sensor tuned to the field. For years, scientists have modelled the possibility of plasma tethers, long-range, field-generated corridors used in theoretical propulsion or energy transfer, but never had one been observed, until now, because whatever the anti-tail was, it's no longer there. It didn't dissolve, it was turned off. The event began with an ordinary wave of solar wind, nothing unusual by itself. Scientists at the Deep Space Monitoring Network were tracking a moderate burst, aimed in the general direction of 3i Atlas as it continued on its post-flyby trajectory near Earth. But what happened next wasn't part of any known model. As the stream of charged particles from the Sun collided with the surrounding space, something strange registered near the coordinates of the comet's core. Instruments calibrated to measure electrical conductivity in localized plasma fields began to spike, not once, but in a steadily escalating pattern. The telemetry resembled a rapidly charging capacitor, as if space itself around the comet had become more than just a reactive environment. It had turned into a conduit. This wasn't a passive interaction. It was an active one. The solar wind, normally scattered or absorbed depending on dust and gas density, was being funneled toward a centralized zone. That zone appeared to be located just outside the newly fractured shell of the core, where the emerged object remained semi-embedded in icy debris. This funneling resembled induction, the kind of electromagnetic alignment you'd find in engineered systems, not cosmic leftovers. The team at the South Pole Array began double-checking their readings. At first, it was assumed to be instrumentation error, but 3 other global observatories confirmed the same thing, a surge in conductivity that appeared to change based on the direction and intensity of the solar wind. What this meant was difficult to process. A passive rock doesn't increase conductivity like that, nor does a cloud of dust. Something within or around the comet's core was behaving like a receiver, not just for light or mass, but for electricity. It's important to understand what conductivity implies. In the vacuum of space, most objects are terrible at conducting current unless they're ionized or artificially structured to do so. What scientists were seeing was the electrical equivalent of a lightning rod, something that wasn't just getting hit by the sun's energy, but responding to it, reflecting it, organizing it. By mid-morning on December 26th, the conductivity curve had grown so steep that it was impossible to attribute the readings to anything natural. It had a rhythm. It followed peaks and valleys in the solar wind's cadence like a language being spoken in volts. Even stranger, after each spike, the core's surrounding gas layer became briefly more transparent, as if energized by the surge. Then, it would dim again, A few researchers noted similarities to electrostatic discharge events in laboratory settings, but nothing this large. This wasn't static cling. This was something attempting to align with, or pull in, energy in a directed way. And it was doing so with increasing efficiency. What this means is still up for debate, but one thing is clear. This wasn't a comet fragment acting on instinct or inertia. Something inside 3I Atlas had learned to respond. As the conductivity data poured in, another anomaly surfaced, one that left seasoned astrophysicists silent. Normally, when a comet is exposed to bursts of solar wind or electromagnetic energy, its temperature spikes, ices sublimate, gases expand, the tail grows brighter. But in the case of 3I Atlas, the reverse occurred. Every sensor trained on the object, from orbital telescopes to infrared detectors on the surface, reported a sharp, sustained drop in thermal output. It began gradually, just a few Kelvin at first, but by midday the cooling trend had become undeniable. The comet wasn't heating, it was losing heat. That goes against nearly everything we know about comet behavior. Sunlight and solar wind should cause surface heating. The surface should become unstable, with jets erupting from pressure pockets and volatile ices boiling into vapor. Instead, the readings were showing stability. Even worse, decline. The thermal signature near the core and around the newly emerged object was flattening. By mid-afternoon, the region around the core registered colder than the surrounding space. Not by a massive margin, but enough to set off every alert. This wasn't shadowing. This wasn't surface reflectivity. It was something deeper, something internal. The area that had cracked open on December 26, the very spot where the mysterious structure had emerged, was not only absorbing energy from the sun, it appeared to be dissipating it through a mechanism not yet understood. Heat that should have been trapped in surrounding gases simply vanished, as if it were being consumed or converted. One hypothesis involved endothermic chemical reactions, a process where energy is absorbed rather than released. But those reactions don't occur naturally at this scale, and they don't explain the consistency of the temperature drop. The change wasn't chaotic. It was smooth, measured, and deliberate. Something was controlling the heat signature of this region, like a finely tuned thermostat. Observers from ESA's Infrared Sentinel Array reported something else, a temporary thinning of the antitail structure during the coldest phase, as if the system had reduced its visible output to minimize thermal contrast. That detail caused one veteran astrophysicist to whisper a sentence no one wanted to hear. It's regulating itself. By evening, all attention had turned from the tail to the interior. Whatever was inside the cracked core, whatever had started to align with incoming solar energy, was now manipulating its thermal output with the precision of a reactor. It wasn't dying, it wasn't decaying, it was adjusting. As more instruments locked onto 3I Atlas in the wake of its core fracture and mysterious thermal behavior, one data stream began to stand out. Not for its intensity, but for its rhythm. Among the billions of charged particles surrounding the object, something was organizing. It started as a minor irregularity in the ion density surrounding the tail's fragmentation zone. Researchers noted that ion concentrations weren't just fluctuating, they were pulsing. At first glance, this appeared to be random turbulence, the kind often caused by uneven sublimation or sudden gas releases from an active comet. But a deeper analysis showed something startling. The pulses were periodic, and they were increasing in regularity. One research team at the European Southern Observatory, running Fourier transforms on particle density, discovered a frequency band that repeated every 91.4 seconds, with micropulses embedded at half-second intervals. This wasn't noise, this wasn't chaos. It was a harmonic structure, buried inside the ion cloud like a low-frequency heartbeat. More importantly, this pattern was independent of the solar wind's own variations. It didn't sync with electromagnetic interference. It didn't fluctuate based on the comet's rotation. In fact, it appeared to originate from a fixed point, the newly opened region of the core. Whatever had emerged was not just passively sitting inside the comet, it was emitting something. NASA's Juno-class spectrometers, recalibrated mid-observation for higher sensitivity, confirmed the presence of distinct charge clustering. It resembled what one physicist described as coherent ion stacking. a phenomenon usually only observed in laboratory plasma experiments. In simple terms, the particles weren't scattering naturally, they were being ordered. That concept breaks many rules of astrophysics. In space, heat, mass, and radiation tend to disperse. Entropy is the law. But 3I Atlas, or rather, the entity now partially emerged from it, seemed to be running in reverse. Instead of losing structure, it was creating it. The environment around the fractured comet was beginning to resemble a boundary, a defined edge between unstructured space and something organized. To add another layer of mystery, the pulses had amplitude shifts every 4 cycles. That detail caught the attention of radio astronomers, who suggested a comparison: data packets. In digital communication systems, a signal often pulses with timing shifts to encode information. What they were seeing in the ion field wasn't just repetition, it was modulation. No agency has confirmed this publicly, but multiple internal memos leaked from deep sky monitoring groups suggest the same question is now under formal review. Could this be a form of intentional transmission? The implications of that are profound. If the pattern is artificial, it raises a new question that no one expected to ask about a comet. Who or what is emitting it? And why now, after the core broke open? There is still the possibility of a natural plasma instability. But the consistency, the timing, and the source point location are all pushing experts to consider an alternative. One that moves the conversation away from astronomy and towards something far less comfortable. Not all patterns in nature are intelligent, but this one refuses to stop repeating. As thermal imaging grew sharper and the comet's core continued to darken, another mystery finally came into focus. Not through light, but through absence. Lunar-based radar arrays designed to scan through cosmic dust were redirected toward the opening in 3I Atlas's fractured shell. For the first time, they pierced the inner cavity and revealed something unexpected. The echo signature didn't resemble ice, dust, or rock. It had edges. At 0437 UTC, the third scan bounced back a high-resolution shape, a defined geometric structure nested in the void. It was narrow, vertically extended, and showed symmetrical facets. But most striking of all was its smoothness. The signal didn't diffuse like it would from rough material. It reflected cleanly, as if bouncing off metal. The first question was simple: could this be a misread? But after 5 independent confirmations using different signal frequencies, the results held. This was no glitch. The structure, roughly 28 meters in height, and tapering toward its base, bore an uncanny resemblance to a spine, or perhaps a spire. It rose from deep within the center of the comet's inner cavity, and appeared to anchor into the comet's denser material below. The walls around it had melted slightly, giving the impression of a release, not a collision. Whatever had emerged had not forced its way out. It had been activated. That word began circulating quietly inside mission groups. The material composition is still unclear. No direct spectrum could be obtained, as the surface continued to repel active scan frequencies. But the radar bounce-back delay suggested a density nearly 3 times that of iron, yet with acoustic dampening properties. In simpler terms, it was heavy, but it didn't ring like metal. Astronomers weren't just puzzled by what they were seeing. They were haunted by what they weren't. There were no cracks in the structure, no erosion. No dust adhering to it. It was sterile in a way nothing natural in space should be. Then came the deeper scan. As the radar beams were focused more tightly, the interior of the shape, at least what could be seen, reflected an internal lattice, not random, not layered like crystal. This was aligned in repeating vectors, like scaffolding or circuitry. Those 2 words were never meant to coexist in a comet. Even the skeptics began to retreat. If this was a natural mineral, it would be the first of its kind, a new element perhaps, or a reconfiguration of high-density carbon chains under extreme pressure. But that theory couldn't explain the pulses. It couldn't explain the temperature drop, and it certainly couldn't explain the synchronized conductivity bursts hours earlier. The object wasn't just sitting inside the comet like an ancient rock, it was central to everything that had happened since the fracture: the behavior of the tail, the loss of thermal energy, the field alignment. All of it pointed back to the shape inside. And the one question that lingered louder than all others was this: was it always meant to come out? The instruments didn't blink. They didn't skip. They didn't stutter. They just went quiet. On the morning of December 26th, as solar observatories and deep space antennae continued tracking the ruptured shell of 3I Atlas, a strange anomaly occurred, one so subtle that most wouldn't have noticed it at all. Within the exposed cavity of the object's now open core, the expected electromagnetic signature was simply absent. The readings began tapering off slowly, as if being choked by something unseen. Then they flatlined. No pulses, no distortions, no noise, absolute stillness. To most instruments, deep space objects always emit some kind of chatter, be it thermal radiation, reflected radio waves, or disturbances in surrounding magnetic fields. But what was being recorded here wasn't interference or weak signal strength. It was the electromagnetic equivalent of silence in a screaming room, an absence so total it stood out louder than any emission. NASA's DSN antennae recalibrated, ESA's deep space probes ran diagnostics, Japan's ARA array even rebooted mid-pass, assuming a software fault. But the result didn't change. Everything pointed toward a pocket of space roughly 170 meters across, at the heart of 3I Atlas that simply did not respond. One hypothesis emerged: shielding. If the material inside the core had properties that absorbed or nullified electromagnetic interactions, this might explain the blackout. But such materials don't naturally occur, not in any object of this type, and certainly not in something exposed to solar radiation levels this extreme. Others proposed a far stranger idea, that the inner core wasn't just absorbing frequencies, but actively dampening them, somehow cancelling waves in a controlled pattern. Like noise-cancelling headphones, but operating on a cosmic scale, silencing not just noise, but the entire energetic fingerprint of space around it. Astrophysicists began to cross-reference older readings. A few traced the silence back to nearly 6 hours before the rupture event, hinting that whatever was inside had been preparing, quietly, purposefully for this moment. The silence wasn't an aftermath, it was a signature. The absence of a signal was the message. And then, just as scientists began adjusting their sensors to focus harder on the core's muted cavity, they heard something else, an echo. It came not from the core itself, but from surrounding charged particles caught in the solar wind, like a ghosted imprint of something heavy pushing through thick plasma. These indirect disturbances had structure, repeating patterns, but the center remained blank. It was as if something inside the comet had turned off the lights and was watching, silently, from within. The silence wasn't just eerie, it was intelligent. When a comet's anti-tail forms, it always points away from the sun, its particles pushed backward by radiation pressure, forming a trail of debris that appears to stretch ahead of the comet's path. But in the early hours after the rupture, something occurred that contradicted not just expectations, but the very laws of known celestial mechanics. The anti-tail reversed. It didn't bend or warp, it didn't flutter in solar wind or react to external forces. It simply, without warning, snapped back toward the core like a taut cord being reeled in. Observatories scrambled to confirm the movement. The Solar and Heliospheric Observatory, SOHO, captured the event first, followed by China's Mingjiang Telescope Array. Over a span of 42 minutes, millions of microscopic ice particles and metallic dust reversed vector, folding inward like birds returning to a roost. It wasn't gravitational. The forces required to draw in an anti-tail so rapidly would have caused distortion elsewhere. Solar plasma, trailing dust, even the object's orbital wake would have shifted. But nothing else moved. Some proposed that a magnetic field had formed, a sudden self-generated bubble emanating from the broken core. But this raised deeper questions. If such a field existed, why had it not emerged earlier? And what kind of material could generate a field strong enough to act against the sun's pressure? Others noticed something even more alarming. As the anti-tail folded in, the particle density began to increase. Rather than dispersing, the tail was being compacted, pulled into a narrowing funnel and disappearing somewhere inside the core. But from the outside, nothing changed. No expansion, no emission, no outward signs of absorption. The tail didn't collide with the object, it vanished into it. And then the reading stopped again. The anti-tail no longer existed in visible form. No reflected particles, no charged dust. Only a residual echo of the movement remained in the data. And for the first time since the rupture, the shape of 3I Atlas became strangely symmetrical, its open core like an iris, calm and centered. Something had pulled the tail in on purpose. That's when a different theory emerged. The anti-tail had always looked like it was being pushed away. But what if it wasn't? What if it had been tethered, held at a distance, restrained, until it was time to reel it back? What if the anti-tail wasn't a symptom, but a system? And whatever emerged from inside the core on December 26th wasn't just collecting dust, it was reclaiming something it had planted. It wasn't visible to the naked eye, but the instruments picked it up instantly. As 3I Atlas drifted past the outer edges of Jupiter's gravitational field, something triggered what scientists are now calling a localized field collapse, a sudden, unnatural drop in the electromagnetic containment zone that had been holding stable within the object's split core. And the moment this happened, everything changed. The internal structure, previously behaving as a tightly bonded composite, began to shift in a way that no natural comet should. Gravitational mapping tools detected a flattening of the field signature, almost like the core had been momentarily pressed flat before bouncing back into its previous formation. But there was no external force visible, no impact, no wave. Just the looming presence of Jupiter's magnetic influence. And then a collapse, so clean it looked deliberate. For those observing from Earth, this wouldn't have been anything spectacular. The object didn't visibly shatter or emit a plume. But to the deep field instruments at NASA's Juno mission and China's orbital array around Jupiter, the numbers were impossible to ignore. The field around 3I Atlas, which had been highly chaotic yet consistent, suddenly vanished for exactly 11 seconds. In that window, no light refracted off the outer shell. The internal thermal readings dropped below cosmic background temperatures, and most shockingly, the newly emerged structure at the comet's center stopped reflecting polarized light entirely. Some speculated it was a kind of defense mechanism, that maybe the core, sensing it was being influenced or watched, shut itself off. Others proposed that it was part of a timed sequence, set to respond when the object encountered a strong planetary field like Jupiter's, but regardless of interpretation, the result was unprecedented. When the field reactivated, it wasn't the same. The polarity was reversed. The tail that had been arcing behind the comet was now reforming in front of it, as if it were navigating backward, or responding to input from something behind it. And all of this, every data point, traces back to a single cause, the gravitational and magnetic disturbance cast by Jupiter's enormous presence. What made it even more disturbing for researchers was the silence. No radiation surge, no debris, no cosmic dust flare. Just a flicker in the field, and a subtle shift in behavior that now has every observatory recalibrating their expectations. Some systems even experienced data loss during the 11-second window, as if the object disrupted telemetry. And one more detail has left scientists unsettled. The timing of the collapse aligned almost perfectly with the rotational shadow of Jupiter, a moment when the giant planet blocked solar radiation and cast its darkest shadow across the space between it and 3I Atlas. It was brief. But in that shadow, the object changed. If this was a natural coincidence, it's one for the textbooks. But for those watching closely, it felt more like a trigger, like something was waiting for the shadow, like the object had been waiting for that moment to do what it did next. And what it did next was even more bizarre. Less than 5 hours after the field reactivation, astronomers around the world noticed a soft pulse, a ripple that seemed to radiate not outward into space, but backward, directly toward the sun. Normally, comets moving through the solar system shed energy forward or trail it behind them in their wake. But this wasn't dust or ionized gas. It wasn't a jet or heat burst. It was something subtler, a coordinated electromagnetic pulse that radiated in a perfect arc from the object's core, not outward into space, but back toward the solar source it had long since passed. For a few minutes, solar observatories were baffled. The pulse wasn't visible in optical frequencies. It barely registered on thermal instruments. But deep spectrum sensors, particularly those tuned for solar dynamics, caught it. A low-frequency wave, behaving more like a memory echo than a physical emission. Its shape was structured, not random. It echoed the earlier pulse that had emerged when the core first opened, but inverted. Where the first had pushed outward, this pulled backward, like a call and response. Even more astonishing was how the sun responded. Within minutes, solar flare activity shifted. A cluster of magnetic filaments near the equator, previously stable, began to destabilize, not violently but subtly, as if something had nudged them, and all of it occurred on the same vector line from the pulse. NASA's solar physics lab went quiet for almost an hour after the data came in. Their preliminary report simply listed it as an atypical radiative disturbance from heliocentric anomaly. But off record, several researchers admitted they had never seen a celestial object send an energy wave backward toward its source, especially after already passing Earth. It raises difficult questions. Is 3I Atlas communicating with the Sun? Is it reacting to something embedded in solar plasma that only now activated? Or is this part of a larger feedback loop we've never understood? More curiously, this pulse wasn't the only thing sent backward. Infrared analysis revealed a stream of high-density particles riding the wake of the pulse, almost as if it had carried something with it. And those particles, upon reaching solar space, did something no one expected. They stopped, not dispersed, not burned. They simply hovered, clustered together at a gravitational equilibrium point just outside Earth's orbit, aligning briefly with the Sun's heliomagnetic current sheet. It looked intentional. By the end of the day, theories ranged from exotic physics to alien relay systems, but one thing was clear. 3I Atlas hadn't just passed Earth and changed. It was now reaching back, toward the very system that birthed it, or at least the one we thought had. Whatever had emerged from its core had memory, and memory in space is never passive. Balloon arrays launched by independent research teams began returning data that didn't make immediate sense. These high-altitude monitoring systems, originally designed to measure turbulence, temperature variation, and ozone behavior, were now picking up shifts in atmospheric pressure that did not match expected seasonal patterns. But it wasn't just the shifts themselves, it was where they were occurring. Rather than aligning with jet stream activity or pressure cells moving in from the Pacific, the distortions were hyper-localized, almost symmetrical in shape, and faintly responsive to the orbital trajectory of 3I Atlas. One balloon array launched over Chile caught a sharp downward pressure spike, lasting only seconds, exactly as 3I Atlas passed its peak angle above that sector of Earth. A second reading came in from over the Indian Ocean, where the barometric sensor on a balloon launched by a student-led team detected what they described as a dimpling of atmospheric tension, a pattern impossible to explain through normal wind or solar weather systems. At first, researchers suspected instrumentation errors, micro-tears in the balloon's membrane, condensation on sensors, or electromagnetic interference from nearby military exercises. But then the patterns repeated, and then again, and this time, across different hemispheres, separated by oceans, at the same moment in time. The odds of coincidence collapsed. These were not glitches, these were signals. Some scientists now believe that 3I Atlas's core rupture created a subtle, pulsing, electromagnetic field that, while too weak to be measured directly, may be interacting with Earth's upper atmosphere through resonance. This theory is still under review, but if it holds, it would mean that the object is not simply emitting light or heat, it's sending pressure waves. But perhaps most unsettling, these distortions have begun to settle into a pattern. Every 4 hours, the same regions experience the same dip, like breathing, a global exhale, then stillness, then another, and the shape of these patterns, circular, expanding. From a single unseen center, a pulse traveling not outward in space, but downward into the layers of our own planet's sky. While much of the West was focused on magnetic data, optical pulses, and tail disruption, the Chinese National Space Administration had quietly deployed a fleet of ultra-high-altitude optical drones. These drones, originally intended for advanced weather surveillance, had their missions quietly reassigned: track, zoom, and record every visible surface detail of the core region of 3I Atlas. What these drones captured on December 26th now circulates quietly among government labs and a handful of partner observatories. The surface of the core, the newly exposed inner material of 3I Atlas, had changed again. At first, its texture had been interpreted as mineral compression, a product of solar baking and sudden decompression. But now, under full spectrum imaging, the surface was showing deliberate deformation. Not random cracks, not explosive ruptures, but segments that appeared to bulge and retract rhythmically. One area, in particular, near the northern limb of the core, was observed to swell by nearly 2 meters over the course of 30 minutes, and then pull back to its original shape. What would cause that kind of movement? One possibility is thermal expansion if some internal cavity is venting. But the Chinese team pointed out that the pattern of swelling didn't match known material behavior. The bulges formed in geometrically even spacing. More than that, some were hexagonal. Infrared overlays from the drone swarm confirmed something even stranger. The bulging points emitted slightly less heat than the surrounding material, almost as if these zones were shielding something beneath. Perhaps a cooler mineral pocket, perhaps something else. One scientist, speaking anonymously to a global observatory chat room, posted a now-deleted message. "We're not watching a shell break open. We're watching it breathe. It's still too early to know what these surface changes mean, but the next drone passes are now focused on one thing, seeing if these patterns evolve. If they do, it may mean that what we're seeing isn't over. It may have only just begun." The quiet rumble began beneath the Pacific Ocean. Not earthquakes, not tectonic shifts, but something more rhythmic, more patterned. On December 26th, at precisely 0341 UTC, hydroacoustic stations scattered along the Pacific Ring of Fire registered a low-frequency pulse that didn't originate from any fault line, magma chamber, or subduction zone. Instead, it came from deep oceanic plains far from seismic hot zones. At first, analysts at the Japan Meteorological Agency assumed it was ship noise or classified submarine activity. But as the data came in from additional stations in Chile, Hawaii, and even distant Australia, the triangulation was clear. This vibration originated from a point in the Central Pacific where nothing of geological interest had ever been recorded. And then came the second pulse, then a third, each spaced roughly 42 minutes apart. Not powerful enough to trigger tsunami warnings, but undeniable in their precision. They weren't echoes, they were initiators. And they were getting clearer. What made the data even more troubling was the vibrational frequency, 783 Hz, the exact same frequency as the Schumann resonance, Earth's natural atmospheric heartbeat, a global electromagnetic frequency caused by lightning discharges between Earth's surface and the ionosphere. Why would vibrations from the seafloor be mimicking a frequency tied to the sky? One theory, now circulating quietly within deep Earth observatories, is that the recent proximity of 3I Atlas and the emergence of its inner core have created a kind of resonance link, a subtle tether between Earth's atmosphere and its deep crust. In this model, 3I Atlas isn't just interacting with Earth from above, it's resonating through it. Another possibility? Something is bouncing the Schumann frequency back at us, but from below. The pulses haven't stopped. As of this writing, they continue, measurable only by the most sensitive instruments, but perfectly timed, like a breath or a countdown. The Pacific isn't speaking in words, but it's not silent either. It may be trying to tell us something. From visible wavelengths to near-infrared, most comets emit light as a result of sunlight scattering off their dust, or from chemical excitation as gases evaporate. It's chaotic, natural, predictable. But what happened on December 26th defies all three. At exactly 05:03 UTC, an array of synchronized telescopes from the Square Kilometre Array in South Africa, combined with Australia's ASCAP system, detected a patterned burst of structured light coming directly from the inner core of 3I Atlas. This wasn't a typical emission flare or tail flicker. This was a coded release, 4 pulses in exact 1.42-second intervals, each peaking in a tight spectral band between 850 and 890 nanometer. Why is this important? Because structured light, in tight, repetitive, encoded sequences, requires more than just gas emissions. It suggests regulation, control, intent. For comparison, the same interval timing, 1.42 seconds, was historically used in some of the earliest coded deep space beacons designed by Earth-based SETI scientists. These timing intervals were chosen because they would stand out as non-natural against the backdrop of chaotic cosmic noise. They were artificial by design. And now, something in 3I Atlas is using the same timing. Researchers tried to dismiss it as coincidence, a rotational quirk perhaps. But then came the angular anomaly. Observatories in Spain and Chile noted that the structured light emissions were directional, not omnidirectional like a flare, but aimed, narrow, almost like a beam, and the target, Earth's night side, directly into the Western Hemisphere. We're not talking about weaponry, not energy. This isn't science fiction. But the implications are just as profound, because beams of structured light, especially near-infrared, are often used in communication. No one wants to say it, not officially. But behind closed doors, teams are scrambling to decode, to map, to trace. Because this isn't just a comet glowing, it's broadcasting, and we've only just begun listening. The Hubble Space Telescope was running a scheduled deep field pass near the trajectory of 3I Atlas. At this point, the inner core had already rotated into a position where its forward face, previously shrouded in non-reflective material, was now exposed toward Earth. But what Hubble saw was not light, not glow, and not reflection. It saw a shadow, but not a shadow cast, a shadow received. This is the paradox. In every known observation of celestial mechanics, shadows are produced when an object blocks incoming light. They're cast away from the source, like Earth's night side when facing away from the sun. But in this case, the core of 3I Atlas pulled in darkness from a region of space that was already fully illuminated. On Hubble's ultraviolet filters, the segment of space that should have shown high photon activity instead registered an abrupt and geometrically negative signal. A void not caused by absence of light, but by something actively absorbing structured radiation, almost like it was receiving a signal, or devouring it. The anomaly held for exactly 13 minutes and 47 seconds, then it stopped. The region returned to normal, no residual distortion. Hubble's engineers thought it was a sensor fault. But cross-checks with data from the Gaia Observatory and an independent balloon-mounted sensor out of Argentina confirmed it. The exact same negative light signature was captured at the same moment from two entirely different positions. So what does this mean? One theory suggests that this was a synchronization event, that the object within 3I Atlas's core was aligning, phase matching, with a source somewhere beyond our immediate detection range, like tuning into a frequency, but spatially, a realignment of coordinates, not just wavelengths. Another theory, far more controversial, is that this reverse shadow was the signature of an incoming projection, that the core of 3I Atlas was not emitting something, but instead preparing to receive something, a transmission, a probe, or worse, an instruction. And if this core is part of a larger network, if it's one node in a distributed structure moving through space, then this shadow wasn't the end. It was the beginning. They told us it was just a comet, a curious visitor from beyond our solar system, a rock with ice and dust and motion. But as each day passed, 3I Atlas rewrote every rule we had about deep space objects. It didn't behave like debris. It didn't glow like a comet. It didn't fragment like ice. It spun in pulses. It emitted structured light. It reversed tails. It silenced magnetometers. And now it receives shadows. We were observers. Now we are participants. Across scientific communities, discussions are no longer about what 3I Atlas is, but about why it's here. Was it drawn to our star, or to us? Is it reacting to Earth specifically, or signalling something through us? Maybe we triggered it, with our radar pings, our satellite emissions, our curiosity. Maybe this encounter was always meant to happen. Maybe this wasn't its trajectory changing. Maybe it was our signal that told it where to go. Because all the data, from the tails inversion to the magnetic null to the Schumann resonance vibrations, points to one chilling conclusion. It's not just near Earth. It's interacting with Earth. And the worst part? It's not done. The emissions are increasing. The pulses are shortening. The light is becoming more structured, more directed. Every signal we've received is part of a system, one that doesn't seem to be slowing down. Governments aren't ready to speak. Agencies are privately warning observatories to remain silent. But the data doesn't lie. And the silence only makes the reality clearer. Whatever 3I Atlas is, we were never its destination. We were its trigger. And the real event hasn't started yet. In the hours after the reversed anti-tail stabilized, ground-based plasma field sensors in Chile and South Africa reported harmonic fluctuations, soft, layered pulses of magnetic interference unlike anything seen from a natural comet. These weren't chaotic. They were symmetrical, balanced, structured. The interference rode along the edges of the solar wind like a song built into space itself. The plasma sheet, a thin, stretched plane of charged particles extending across the solar system, started resonating with low-frequency undulations. Scientists initially blamed solar activity, but something was off. These pulses had rhythm. They returned at timed intervals. Each one came from the precise location where 3I Atlas's core had reversed its magnetic polarity. Then came the real surprise. The pulses weren't identical. They evolved. Slight modulations in frequency and amplitude began encoding patterns that resembled language. Not human language, but patterned enough that machines trained on known physical signals couldn't make sense of it. They weren't chaos, but they also weren't noise. Observers at the DSN, Deep Space Network, attempted to triangulate these harmonic bursts. Each beam traced back to the very curvature of the anti-tail's reverse trajectory, like it wasn't reflecting sunlight anymore, but projecting data. Radio astronomers cross-referenced the event with prior cosmic sources and found no known corollary. It was neither a quasi-stellar object nor a pulsar. It was local. It was moving. Meanwhile, amateur astronomers began noticing something visual. The tail's outline now appeared thicker in long exposure photography, almost like it had a mirrored double, a faint echo. But only when aligned with the same direction as the harmonic pulses. This suggested a coordinated orientation, as if the object were syncing its activity with the magnetic contours of the heliosphere. That's when a few theorists quietly dropped the term natural body from their press materials. Because at this point, even the skeptics had to admit, this wasn't random, and it wasn't dead rock. Something was organizing the chaos. As telescopes followed the path of 3I Atlas through its final shift past Earth's orbit, they noticed something haunting. The space behind it, the very region its tail had once trailed through, wasn't heating up from residual solar energy or plasma interaction. It was cooling, significantly. Typically, a comet's ion tail leaves a wake of disturbed particles, often temporarily hotter due to solar wind compression. But in this case, the wake behind 3I Atlas showed the opposite. NASA's infrared sensors aboard the Solar Dynamics Observatory detected a narrow zone of anomalous cold stretching thousands of kilometers. This wasn't the absence of heat. It was the active suppression of it. Some hypothesized a rare vacuum effect, where particles had been cleared to such a degree that even radiant heat struggled to propagate. Others saw a more disturbing possibility. Something was absorbing energy from its environment, not reflecting it, not scattering it, absorbing it, and leaving nothing behind. The cold zone deepened over the next 6 hours. Instruments aboard the Parker Solar Probe picked up drops in particle velocity as it passed through the edge of this space. It was almost like hitting a magnetic dead zone. Momentum drained, turbulence vanished. No friction, no noise, just stillness. Then came the visual cue. As one amateur captured a time-lapse from Mauna Kea, the tail of the comet pulsed once, and then thinned. Not because it dissolved, but because part of it seemed to get pulled back inward, back toward the core. It wasn't dispersing, it was feeding. One analyst used a terrifying term in his closed report to ESA, heat siphoning. No one wanted to say it aloud, but everyone was thinking it. If the core of 3I Atlas had opened, and if it was drawing material in, then maybe that cold zone was not a leftover anomaly. Maybe it was part of a system, one we were watching for the first time. Days after the anomalous cold zone appeared, multiple observatories captured a new, impossible shape forming behind 3I Atlas. The tail, long thought to be a passive stream of ice and gas, had begun to curve, not due to solar wind but inward, toward its own path. It was forming a spiral. The structure wasn't chaotic, it formed loops, perfectly aligned arcs that obeyed no known solar mechanics. This wasn't gravity at work, this was choreography. Simulations tried to replicate the motion under known physics, and they all failed unless one added an external force. Not a push, but a guidance. Almost like magnetized control, or intentional steering. What disturbed physicists most was this. The curvature implied acceleration. In other words, 3I Atlas wasn't just drifting, It was preparing for a maneuver, possibly a slingshot, possibly a return. A looping tail of this kind had never been seen before, not in comets, not in asteroids, and certainly not in objects thought to be interstellar pass-throughs. But here it was, coiling, collecting, tightening like a spring. And all the while the cold zone behind it grew wider, like the comet was gathering fuel not from the sun, but from the void itself. Onboard software at ESA's JUICE mission had to be manually overridden when it incorrectly flagged the formation as an artificial gravity event. The math made no sense for a natural rock, but it fit perfectly if the tail wasn't debris, but a tool. And then came the real shift. On December 24th, long-range radar imaging captured what looked like a dense, structured core. Not a loose mass of ice and dust, but something hard, smooth, reflective. For the first time in months, one sentence began circulating in classified Slack channels between researchers. It's not orbiting anymore, it's deciding. As 3I Atlas coiled its anti-tail and began forming spirals in its path, ground-based radio telescopes started picking up a consistent background signal across multiple observatories. At first, it was dismissed as instrumentation noise, until 5 stations across 5 continents confirmed identical waveforms. The frequency, just below the threshold of human hearing, about 17 Hz. It wasn't a radio burst like FRBs, it wasn't a solar flare echo, it was a continuous hum, a vibration through space that moved with the object's path. But here's where things got chilling. The signal modulated in rhythm with the comet's tail coils. As the curves tightened, the hum changed pitch, not randomly, but predictably. Like a musical instrument tuning itself. Audio engineers and astrophysicists collaborated to sonify the data, boosting the frequencies into the audible range. What came out was unsettling, a deep, pulsing chant. Not melodic, but ordered. Engineers compared it to the THX deep note, except it looped, exactly every 108 seconds. Theories began forming. Was it vibration from internal structural reorientation? Was it magnetic friction against the solar wind? Or something worse, a broadcast? Some speculated the wake behind 3I Atlas had become an energy field, or a corridor of enhanced resonance, similar to how sound behaves in a cathedral. The tail wasn't just ejecting particles anymore, it was creating structure in space. Satellites that flew near the wake experienced brief sensor anomalies, especially magnetometers and gravimetric sensors, which picked up spatial fluctuations inconsistent with known forces. Some sensors registered null gravity zones lasting less than a second, as if gravity had inverted and returned. Still, official sources remained quiet. NASA published a generic explanation about interstellar objects and their unpredictable behavior. But by then, too many labs had already downloaded the raw wave data and started experimenting. One open-source team found that, when plotted visually, the hum's harmonic signature resembled a torus, a self-reinforcing loop. That's when someone asked the unthinkable, is it charging? On the evening of December 26th, telescopes across the Western Hemisphere experienced a strange phenomenon. 3I Atlas momentarily disappeared from visual observation, not because it was blocked by another object, not because it fell out of range, but because it simply stopped reflecting light from several vantage points. Entire imaging sessions came back pitch black where the comet had just been. Infrared scopes could still see the heat signature, but visible light was gone. Curiously, the blackout wasn't universal. Observatories located in northern latitudes still saw partial reflections. It was angle dependent. This wasn't a case of an object rotating and hiding its reflective side. It was like the object itself had changed surface properties, absorbing photons or bending their trajectory. Amateur observers dubbed it the Black Lens event. NASA scrambled to reroute Hubble, which was observing a different quadrant. When it finally caught up, the object had become visible again. But its albedo, the measure of how much light it reflects, had changed. What had once been icy and volatile now behaved like obsidian, and it didn't change back. This alteration was followed by something even more peculiar. The anti-tail, previously bright and sharp, dimmed drastically, while the cold zone intensified. Whatever process was occurring inside 3I Atlas, it now seemed to be creating a cocoon of light absorption, possibly for stealth, or perhaps something stranger, like energy harvesting. physicists quietly released a paper proposing meta-reflectivity, the idea that the surface was now behaving like a metamaterial, capable of responding dynamically to light. But metamaterials are engineered. The paper was removed within 24 hours. On December 26th, a bizarre and widespread tech anomaly occurred across Earth's space monitoring infrastructure. Satellite operators began reporting bandwidth fluctuations, not signal loss, signal gain. Data compression rates improved drastically. Files that once transmitted at 50 megabytes per second were now compressing and uploading at 5 times the efficiency. No new firmware, no new protocols, just faster throughput. This anomaly wasn't localized. It affected Starlink relays, NOAA satellites, even deep space network backups. At first, companies were thrilled, then concerned, because when engineers dug deeper, they found something else. The compression algorithms were subtly changing, not in syntax, in efficiency logic. Entire redundancies were being bypassed or restructured in real time. But no one had pushed updates. The pattern? The optimization peaked when satellites passed near or aligned with the wake of 3i Atlas. A few researchers noticed the spike mirrored the hum's pulse timing. 108 seconds. That meant something from the object was affecting digital compression, not mechanically but through waveform interference, possibly quantum-level packet shaping, or a form of resonant compression Earth systems weren't built to resist. The scariest part? After each satellite exited alignment, the improved compression stayed, as if something had rewritten the onboard logic. Silently, permanently. Several security agencies ordered emergency audits, fearing a cyber intrusion. But the audits found no breaches, no foreign fingerprints, just cleaner code. A few engineers broke ranks and posted their logs anonymously. It's like the hardware itself learned how to think better, but from what?